In this video, I will show how we can upgrade a version of a database system to the latest version in SQLancer. So first of all, where do we actually find the version that SQLancer currently supports of a given database system? This information we find in this main.yaml file. For example, here you can see that we run the test for MySQL, and there you can also typically see what kind of version of the database system that we are currently testing against, and this is the version that is currently supported. Unfortunately, this version is not always the latest version of the database system, right? Often we cannot keep up with the development, which means that this version is outdated, which is then of course less useful for testing because we won't be able to find any new bugs, for example, that are being introduced in a certain system. Thus, it's basically important that we often update the version. Also, for some systems, namely embedded database systems, we also need to consider this pom.xml file where we specify the database driver, the JDBC driver that is currently specified. And for example, in DuckDB here, the version of the JDBC driver and the database system is the same because the JDBC driver actually includes the binary of the database system. Now, in this video, I will basically show how we can upgrade the version of DuckDB based on an older pull request that updated an older version of DuckDB, the one that we have just seen, to version 1.1.0. And basically, I will replay how I approach this issue of upgrading in that context. So first of all, how do we find out to which version we should upgrade? There, it typically is helpful to, for example, search for the latest version of the JDBC driver that's currently supported, so we can upgrade to that version, or also the latest release notes of the database system. And so here we'll upgrade to version 1.1.0, again to basically have the same version as the pull request here. Now with that, let's first go to the command line. You can see that I've already checked out this older version, namely the one that predates this pull request here. As you have also already seen, we have now version 0.4.0. And what I can do first is just to see whether we can still successfully build this version. And then also run it. Right, so now I am trying to execute DuckDB. And then the oracle example here is the eternity logic partitioning word test oracle. And as you can see, the currently supported version does not immediately trigger any issues. Now, let me stop again the execution here. Now what I'm doing is I'm upgrading the version here in the pom.xml to the latest version that we assume, which here is 1.1.0. Saving, and now I'm building a SQLancer again. Using Maven package here basically ensures that we are using the right version of the JDBC driver. And now executing SQLancer again on this updated version. And what you can immediately see is that we are hitting a lot of errors, right? So now stopping this again. So let me first explain at a high level how we approach updating. Basically, first we need to address any kind of errors that pop up, right? Because typically we want that no errors on the current version are being reported, basically by declaring errors either as expected errors, if we cannot reasonably prevent them, even if they do not indicate bugs, or by reporting potential bugs to the developers and then also preventing that we generate them again, so that again, typically SQLancer doesn't issue any errors because all bugs have been reported and then we prevent the execution, or because we declared everything as expected errors. Or the third is actually that if, for example, a feature was changed or removed, that we also account for this in the source code. And after this, typically, we also try to add any new features that have been added in a certain database version. Right? This can, for example, be new operators, new data types, new keywords, and so on. Now, what we could do now is we could already start addressing any kind of issues, right? We can, for example, go to the logs directory here. Here we have DuckDB. And then, for example, yeah, let's actually open the first one here. We can now try to understand what happened here on this file. But as you can see, this might actually involve quite some effort. Now we could use, for example, a test case reducer to reduce the effort. But one easy trick that we can apply is that we make the test cases that are being generated smaller so that they're easier to debug. And then we first try to fix all the easy issues. So how do we do that? Basically, we need to find the right options to execute. So first of all, we have here, let me actually check again the output. Scrolling up here. So here, for example, we have the number of queries and maximum inserts, number of insert statements. So we can already set this accordingly. Right? So here we had maximum number of inserts. And for example, we can set this to 1. It works. And then we had the number of queries, I think, which we can set to 0. So initially, we actually don't execute any queries at all, which allows us to first address any issues in database generation. And finally, what we can also do is we can set the maximum expression depth. I'm not actually very sure what the value here was. Let's just try. Max expression depth 1. Let's perhaps check in the source code, which is in the main options. Oh yeah, max expression depth is, so the reason was actually that here we specified this as an argument to DuckDB, not as a general option. Right, so now, as you can see, we are already generating significantly simpler test cases. Let's just generate some of them so that we can select the simplest one and try to address those first. So quitting now. Now let's look at some of the output. We can perhaps order here by size first, so we can look at the smaller ones first. Yeah, so here we have, for example, 89. And here we have referenced update column row ID not found in table. Specifically here, we tried to update T0, namely the row ID column, and this caused an issue. Right, so let me just copy that first. And we can try to just see what basically happens in the old version and what happened in the newer version. So here, this is the old version. So here in the old version, we see the error column with name row ID doesn't exist. And here we see the error reference update column row ID not found in table. Right, so basically what we see here is that the error message changed and already gives us some hints of what might be the issue. Right, so basically, likely what I suspect based on this now is that previously we already considered it as an expected error, but then the error message changed to a new one, which is now it's no longer recognized as an expected error. And so we can now go to this DuckDB insert generator, because this is the statement that triggered the issue here. Then we can look for the expected errors. So here we have some insert errors. So here we can see this error, right? Column with name row ID does not exist. And here we actually already see an explanation, right? Because at the high level in SQLancer, we can always decide whether we want to declare an error as expected if we cannot easily prevent it, In this case, at the time when we implement this functionality, DuckDB didn't have a way to determine whether a table has a primary key or not. And that influences basically whether a row ID is present or not. So perhaps this changed over time and we would be able to be smarter now with updating values, taking into account whether the table supports a row ID or not. Here now, for the time being, I will just update the expected error and leave checking whether the row ID actually exists in a table as a future enhancement. But so here, basically now I need to update this error. Saving this now. And now we could, for example, commit this change because we already addressed the first update issue here. So with that, let's now just build again and continue executing the next test cases. Okay, let us execute SQLancer again with the same command line options as before. And we continue seeing some issues. So let me terminate the execution now. And let's inspect again some of the test cases. So what you can see here is that we get an error, not implemented error, creating partial indexes is not supported currently. So again, let me get the actual statement that encountered or caused us to encounter the issue. And let's check again what the different versions of DuckDB produce for this. So here actually the earlier version seems to issue no error. And for the new version, we get this error that it's not supported. What does this mean? Based on this, and of course this might require some further research to confirm it, but it seems that partial indexes were already not supported in the earlier version, but then DuckDB didn't issue an error. So now perhaps what we actually want to do is we do not want to ignore the error because we will never be able to successfully create any partial index and it would never trigger any interesting functionality. So that rather than that, we would want to remove the functionality in this case. In order to do so, we should go to the respective generator, which here is probably some index generator. So here we have DuckDB index generator. Then you can see here that we have a work clause that we might generate, which basically is a partial index. And now I'm going to remove this statement here. So with that, we can again build SQLancer. So here I have a warning that I first need to fix some import that is redundant. Let me try again. Great, so build again. Now let's execute SQLancer again. We still encounter some issues. So let's analyze those as well. Hitting execution again. And now let's inspect the test cases. So here we have an issue that we cannot mix values of type timestamp and Boolean in between clause. Yeah, perhaps let's try that one because it's only a single statement here. Let's first execute it on the latest version where we observe this error, right? And now also on the older version. So on the older version, we do not observe an error. So this was able to execute it without complaining. So here, if we would stare at this for a while, we would basically identify this potentially as an expected error. So it depends a bit on the database system, actually, whether we have a typed or untyped expression generator. So you can read about the differences in the contributing guide. But basically, in this case, it would be difficult to prevent this error in DuckDB, given the current sequence of the current architecture of SQLancer. So here we'll identify this as an expected error. Given that this is an expression, it's actually not very specific to the create table statement. We could have also encountered this expression, for example, in a select statement. So now we basically need to look for the expression generator and specifically for the expected errors associated with an expression generator. So for this, we can actually directly go to DuckDB errors. You can see that we have here an get expression error. So we could first check if there are any similar expected errors. Does not seem so. So perhaps let's just add this one. Now here, we might suspect that not only timestamp and Boolean are affected, so we might try to generalize this a bit, which we can do by specifying a regular expression. But actually in that version of SQLancer, I think regular expression matching in expected errors was not yet supported, which is why here we just remove part of the error message so that only the between clause issue and explicit cast remain. So saving again and going back to SQLancer, where we again now can build SQLancer and see again whether any issues remain. Okay, let's execute it. Okay, we still encounter some issues. Let me quit the execution. And what we see here is actually quite similar to the error that we have just observed. We can already see here that we have a case expression, and we are told here by the type checker of DuckDB that we cannot mix these types of decimal and varchar in a case expression. And so here actually we would need to declare a very similar expected error as before. So we could either do that, or we could further, for example, try to generalize the expected error here, which is what I will do here now to progress more quickly. Building again and executing. Here we are still seeing some errors. Let's stop the execution and see what these errors are. So here we can see that the error that we're getting is that we have an order by, and we have a floating point number that we pass. And the DuckDB is telling us that ordering by a non-integer literal has no effect. So let's try to double check this. So we have 4 SQL statements now that we need to execute. And here first we have the latest version where we, oh sorry, I forgot to paste the C of the create here. So here we get the error that we have just observed. What do we get in the previous version? So in the previous version, we didn't encounter any error. So for this, let's perhaps see how the view generator generates order by clauses. So here it seems that we used the random query synthesizer in order to generate them. Here we have the generate order by. Let's see if we find the DuckDB implementation. See here we are creating ordering by terms. Where do we get the expression from? Here, and here, as you can see, we just generate random expressions. So how could we address this now? We could try to generate only meaningful order by clauses, but that could also be that could also limit the search space that we have. Right? For example, we might want to generate random integer clauses, but not floating point numbers. We might want to generate column references and so on. Just to show this, here we have the latest version, right? And now let's go back to our test case. And here, now if we would say order by 1, that actually might work, I think. Yeah, so here DuckDB doesn't complain because an integer value basically references some columns in the fetch clause. So here perhaps for now we can again decide that we want to declare this as an expected error rather than restricting the generation of features within the expression generator here. Now where's the right place to add the expected error? Let's perhaps check. Perhaps actually we can add it in the query synthesizer for order bys here. And so here we have some expected errors here. Okay, we actually do not. Let's see who calls the select statement here. Is it only the view? Also here actually we have a group by errors. Perhaps actually we need to have some separate order by errors. Oh, but here, oh yeah, here also we have this call, right? So let's add order by errors. And also here, order by errors. And then we can add this expected error message. Here we didn't save yet. We create a method here. And we add this error message. Order by non-literal. Literal has no effect. Saving here. Let's see if that builds. We are running again. He's still encountering some issues. So here, column, oh, sorry, let me stop that. Here it says that a column must be part of a group by clause. Let's actually look at the text files. Seems now actually we're already observing fewer errors than before. Let's extract the statement here that caused the issue. And let's execute it. In the latest version, again, we should observe this issue that we have just seen, right? This error. What about the old version of DuckDB? Yeah, so here it seems like the error message changed. Must be in the group by clause or be used in an aggregate function or must be part of an aggregate function. But so here it already seems like just the error message was updated. So copying here now the new error message, going to the DuckDB errors. And there we have seen already before that we have a group by a category of errors. Yeah, so we can now update the error message. Let's build SQLancer again. Executing it. Okay, seeing some errors again. The frequency seems to be dropping though. What do we see here? So get column type actually seems to cause an issue here. This is in the DuckDB schema class. And we had which line? Line 1214. Also, it's not recognized. And basically, we have null in quotes here. Do we not have null type? We actually have one. Let's see also where the method is called here. The table columns 267. Also, we have here some pragma. So let's try to reconstruct what happened. Here we wanted to create a view, and then perhaps we wanted to query the columns of the view and specifically the data types. Let me copy that and see if we can reproduce the issue. That's the latest version. So here we have a null data type. What about the old version? For the older version, it's actually not very clear to me why that doesn't work. It says here that this table function, which is the pragma table info, cannot contain column names. But actually, here we are referencing v0, which is the view, right? Not a column name. So I'm not very sure, but it could just be that previously this functionality was not supported, and now we can encounter some null data types in views. Right, so we could perhaps first try to see if just the null value here was renamed, right? That previously it was not in quotes and now it's in quotes. For now, in order to be able to proceed, I will just add this additional case here where we have null in quotes, and that's also a null data type. let's see. Building again and executing. Almost, we at least proceeded to the first information output before encountering an issue. So here it seems an issue related to group by, and we encountered it in the create view statement. So this actually seems quite similar to the error that we had before. So let's see what happened. So we had the DuckDB errors class here, and then we had the group by must appear in the group by clause or be used in an aggregate function. Oh, perhaps before I made a mistake updating this, or perhaps we have now both versions. So I'm not really sure now which one it was, if I made a mistake before, or whether there are now two different kind of error messages. But let me just now also specify this alternative version. Building now and executing. That seems like a good sign. So it seems that likely we have addressed now most of the issues that happen given the restrictions that we have imposed on SQLancer. So what will be the next step now? The next step is basically that we need to lift some of these restrictions, right? For example, we could now first try what if we have more than one insert statement? Would we encounter any additional issues? Yeah, so actually it seems we would encounter some. Let's just have a quick look. I see here we have perhaps some changes related to duplicate values in columns. So we could proceed by trying to fix those, or perhaps we could try like a higher expression depth. And so we could try to lift that restriction. Okay, it seems we don't encounter any issues immediately. Typically, many of the bugs are actually triggered if we execute queries. Currently, we're not executing any queries yet. We could try to lift that restriction, address the issues there. Yeah, we can see that we have actually a similar order by issue as we had before. But overall, I think now we've understood how we can approach addressing such issues that we observe when upgrading SQLancer to a newer version of a given database system. Quitting again here. And again, to remind you, after we have now addressed all of these issues and SQLancer works without reporting any new issues, only then should we proceed to adding some new features that the new database system supported. Also, it might be that you identify some real bugs that have been introduced. For example, if one of the test oracles, let's say a TLB word test oracle, says that the cardinalities of the two result sets differ, this, for example, typically suggests a logic bug. Or it could, for example, be that you encounter an issue here, an error message that says that you have encountered an internal error within DuckDB. In this case, you would also want to report that error. Also, we have a common pattern within SQLancer where we specify bugs to be known. So since we don't have one for BugDB, but here, for example, for another database system, TiDB, you can see that we first of all report an issue, and then we add a field to this class here. And as long as the bug is not being fixed, we basically try to work around this issue. For example, here, this bug likely causes some assertion failure within TiDB. And as long as this issue is not fixed, we just ignore any error messages that have this string part of the error message. For example, if we cause a crash, then sometimes we also want to restrict a certain expression, for example, from being generated. And then once the bug is fixed, we can again lift this restriction and then allow SQLancer to generate a broader range of features. So I hope that was useful, and thanks for listening.